All right, guys, today we're sitting down with Dr. Jose Antonio. So first off, thanks so much for joining us today. Really, really excited to chat about essentially research. This is something that I think a lot of people get wrong, including myself sometimes. And so I think it'll be really great to get your perspective on just kind of how the process works, some of the limitations, and some of the real major benefits that exist through research.
Yeah, I mean, it's a good question. And I think partly because, with the advent of social media, people are clamoring more for scientific research as it, relates to, whether it's exercise or nutrition. And I think, one of the things that's lost on those who may not do research is, I always say experience is a brutal teacher. And just to give you a real life example, I had published a paper. This was fairly recently, it was like 6 months ago. And immediately people on social media, sort of the typical question goes like this: why didn't you measure X, Y, and Z? Why didn't you do that? And I think part of that shows sort of the naivete of people who don't do research, in that typically what scientists do is narrow the focus down quite a bit, which means you have to be very picky in terms of what measures you do. Because when you have limited time and limited resources, you can't possibly measure everything. Real life example, the initial studies I did on high protein diets, where I just wanted to see, this was a simple question: what happens when you get bodybuilders who just eat a lot of protein in the form of whey protein? We weren't looking at any mechanism, so we were asking a very simple question: what happens to body composition? And we found that unless you change your training, body composition doesn't change. The primary critique of the study was that mechanistically we didn't determine how that happened. Was the thermic effect of protein? And I think what's lost is those is very, in a way, they have to be very picky as to what questions they're asking. If you look at, for instance, studies looking at the thermic effect of protein or non-exercise activity thermogenesis, you don't see body composition data typically. It's usually they choose one or the other so that you can narrow the focus down. And I think for the lay public, they need to realize that science is great, but we all know it has its limitations. In fact, scientists are they're the first ones to tell you all of these studies are quite limited, in that it's almost the conclusions you can make from these studies are limited to the specific sets of circumstances that you're studying studying a certain phenomenon in. So, the process, and sorry if I'm a little long-winded, but so let's say the process starts like this. Me sitting around with my friends saying, hey, I have an idea. Let's do this study. Well, let's look at the effects of creatine on the brain. So ideation, that's always the fun part. Anyone can come up with an idea. Now you have to figure out, you got to put pen to paper and say, okay, so if this is the idea, now we got to figure out how to limit what we're studying. So if we're looking, let's say, the effects of creatine on the brain, in human beings, you cannot take their brains out. In rats, you can take their brains out. So that automatically limits you if you're studying humans. So if you're studying humans, okay, well, what measures are there to look at brain function? Well, there's a whole list of cognitive measures, mood measures. You can't do all of them unless you want to do a 5-year study. So you pick and choose the ones that you think fit best, depending on what you're asking. So you design the study, you submit what's called an institutional review board proposal, or IRB proposal, usually to a university, but you could do it externally. That has to be approved. So that's sort of the first vetting process. And then once it's approved, now you can start recruiting human subjects, actually undertake the study, which sounds easy, but it's actually quite difficult. And then once you have the data, you present it as a poster at a conference. And then ultimately, sort of the grand prize is you publish it as a paper. So if you and I said, hey, let's do a study on whatever, the effects of squats on sprint speed. Let's say you and I decide we're going to do that today. I would say, okay, let's say in about 9 to 10 months, we'll actually have a paper that's publishable. So in a way, when you read a study, just think to yourself, wow, this was actually started a year ago, oftentimes longer, depending on the scope of it. So, and that's just the process. It's not a super fast process, but you have to go the process nonetheless, because that's just the way science is.
Right, and that's something that I think is not necessarily apparent at face value, right? What you said exactly about, coming up with the initial questions and saying, okay, well, what is it that I'm actually trying to look at? Because you can't exactly prove or disprove everything in every single study, or else it would just
Right.
be, you'd never get anywhere. And that's kind of, I guess, leads into the next question. So can you just give like a brief overview of what are some of the different types of studies that do exist, and I guess what's the relative efficacy, right? Everything from just like maybe an opinion paper all the way up to like a meta-analysis or systematic review.
Okay, that's a great question, because I think there's a lot of misconceptions about this. In our field, and I'll use the broad term sports science, and sports science encompasses sports nutrition, exercise training, strength and conditioning, et cetera, et cetera. In our field, the number one way to study any kind of phenomenon is through a randomized controlled trial, or RCT. What that means is the investigator scientist has to collect data that's original. So that's why I call it original investigations. That is the bread and butter of our field. Now, everything below that is it's sort of like that's at the top, and then everyone else is sort of vying for second, third, or fourth. I mean, it's not even close. You have to do original investigations. Now, I have noticed that in our field, people love these meta-analyses. And oftentimes they'll put a meta-analysis at the top of the heap saying, this is the ultimate in terms of knowledge that we accrue in our field. And I'll be honest, that's absolute bullshit. It's meta-analyses are not. In fact, it's interesting that when I was in grad school, and this was a long time ago, I got my PhD in the 1990s, meta-analyses were actually rare. And here's why they were rare. Typically, the people who did meta-analyses were the actual experts who did the RCTs in that field, meaning if someone wrote a meta-analysis on, let's say, training and skeletal muscle hypertrophy, they were actually the ones who did the research on training and skeletal muscle hypertrophy. But what we see now is a proliferation of meta-analyses written by people who actually don't do any original investigations in that particular field, which I've always found kind of odd. It's like, how can you write a meta-analysis on caffeine but have never done an RCT on caffeine? And I think part of it is, I think there's a laziness that some people have. They're like, well, you know what? I don't want to do the study, but I'll take everybody else's studies, put it together in a paper, come up with my own statistical analysis, and voila, here's my paper. But at the end of the day, in our field, meta-analyses, and we'll throw review papers in there as well, they would not exist if it wasn't for randomized controlled trials. Randomized controlled trials are the bread and butter of our field. Without that, there is no field. It's everybody guessing, everybody arguing, nobody knowing what to rely on. So we have to have more original investigations, as opposed to, we don't need another review paper. We don't need another meta-analysis. We need more original investigators. And I think that's kind of lost in the, when I go on social media, whether it's Instagram, Facebook, or Twitter, I can tell most people don't know really what an original investigation is versus a review paper versus a meta-analysis. They always refer to all of them as studies. Well, this study showed this. Well, no, that's not a study. That's a review paper. Well, this study, no, that's a meta-analysis. That's not a study. Studies are original data. It has to be original data. Otherwise, you're just rehashing what someone else has done. And I'll be honest, there are people who've made careers literally summarizing what other people have done. And the general public doesn't know the difference, which is, I find, rather odd, to be honest.
So it's really funny that you said that, actually, because I had someone send me, I can't remember if it was a systematic review or meta-analysis a little while ago, and there were two studies in it.
Oh my
Right? So it was a compilation of two studies, and they wrote a meta-analysis, and I was like, is
No,
this
wait.
really necessary? Like,
Wait.
what do we need this for? Right? So
Was it literally, you're not kidding, are you?
no, I'm not joking. That's not an exaggeration. There were two studies. And I haven't read it yet. I remember looking at it, and I was just like, no, that must be wrong. And yeah, it's funny because, like you said, in the last, obviously you're way more dialed in than I am, but in the last, like, let's say 5 or 10 years, there's definitely been a big push towards meta-analysis, and everyone's wanting to pump out these big reviews.
Yep.
And so that does kind of change the landscape, especially if you are putting a little bit more weight in, let's say one style of publication versus another. And so what, I guess that kind of, I wanted to talk about one thing, I guess, before we maybe get into some of the details about that. With regards to funding, funding is always a topic of contention with people.
Yep.
Oh, well, that's funded by Big Pharma, that's funded by this. Now, I've actually seen a paper, this was, God, I don't know what it was, but essentially it was looking at the actual impact that funding does have on the outcomes. And it did
Mm-hmm.
actually show, that the results skewed positive in their favor, but it wasn't
Right.
meaningful to any large degree. Now that was just one paper that I read a long time ago, but I'd love to hear your feedback on that, and also learn about what kind of I guess barriers or safeguards do we have to prevent any sort of data tampering in situations like that.
Yeah. No, it's an interesting question because way back, I guess let's go back to the early 2000s. When myself and a few of my colleagues, we decided to form the ISSN, the International Society of Sports Nutrition. Part of the reason we did that was precisely because there were no studies by supplement companies at all. I mean, they funded nothing. They made claims, but they couldn't really support their claims. So some would make outlandish claims, others would make sort of benign claims. But we figured, why don't we introduce people in the industry to scientists? And that way, hey, you could actually do studies on products. So that was the impetus. And since then, there's been a huge growth in the amount of industry-funded studies, which actually is a great thing, because without industry funding, there wouldn't be any studies. So from purely a pragmatic standpoint, it's a great thing, because sports nutrition now is a viable field of study that there are at least grant dollars available. Now, I'm familiar as well with, I don't know the name of the paper where it showed that if a study was funded on a product, it tended to show positive results of that product versus one that was not funded. Now that could be, there's two reasons to that. One, it could be, well, you could be a cynic and say, well, it's because scientists are somehow slanting the study to find positive results, which if you read the methods, I don't know how you could slant the study per se. It's sort of like this. If someone wants to fund a study on an energy drink, we know the primary ingredient in an energy drink is caffeine. And as scientists, we also know there are certain tests that are probably best for determining if caffeine has an effect. Is that showing favoritism? No, it's just being smart. There's just certain things caffeine will help and certain things it won't. But really the bigger question is, does the funder somehow influence the scientist? And that's where it's a question that you can't answer, because you can't get in anyone's mind. You can't say, hey, because Gatorade funded your study, I can see why you got positive results with Gatorade, because now they're more apt to fund your studies. And what's funny is that that's the same critique you'll see with federal funding. In fact, if you get federal dollars, let's say NIH dollars, the same thing kind of happens. It's like, well, you have to show something in terms of, let's say you're being funded for the effects of nutrition on let's say sarcopenia or osteopenia. You better show something in your data, because if you show nothing, what are the odds of you getting funding again? Well, probably less. If you're constantly showing null results, why would they keep funding you? So in a way, there's this weird drive to show something happening. And I don't think it's just private funding per se. It could be funding in general. But I think there's not many people in sports science. I mean, it's kind of a small field compared to, let's say, cell biology or neuroscience. I mean, we're tiny. But for the most part, these are hardworking scientists who, to them, the data is the data. And they don't typically have a sort of a bone to pick. There's no fight for them. To them, it's just they want to do good science. But things like that, like it's almost impossible to find some nefarious intent with a scientist, to be honest.
Yeah, and I don't know if I'm off base, but I tend to sort of suspect that some of the tampering with evidence research is somewhat specific to the field. Like I personally haven't seen tons of really egregious issues in the sports science field, because like you said, it just works a little bit differently. Whereas maybe in pharmaceuticals or something like that, there potentially could be more benefit financially. There could be a little bit more pressure from different groups and things like that. Whereas I don't know that squatting below parallel, or proving that that's potentially
Right,
better for your strength is going to really yield a whole lot of
right.
benefits for your career or you financially,
Well,
right? So,
well, you know what's interesting? I'm sorry to interrupt you, but there was a case, and if you probably just Google this, you'll see it. There was a scientist somewhere in the Northeast who literally, I think, fabricated data, up to 20 papers on resveratrol, on the ingredient in red wine.
oh,
And
okay.
he was getting a lot of funding for it. So clearly, there was, when people are funding and they're saying, wow, you're coming up with some pretty cool results, I'll keep funding you. But he was literally just making shit up, which I was like, holy jeez, you're going to get caught eventually, because here's what happens.
Yeah.
Other people will try to repeat your studies. They're like, I can't get any of this stuff. And in a way, people say, well, that's sort of the checks and balances in science. Someone else will try what you're doing. And if they can't find it, then it's like, okay, something's weird. Something weird's going on.
Yeah. And that actually happened very recently with, what is his name? Barbalo? Matthias Barbalo? Um,
In Brazil.
yeah, yeah. So he had a bunch of really, like, he had a bunch of research where there was like a bunch of anomalous data sets that he presented. And then I think Andrew Vygotsky and Greg Nuckols and a handful of other people looked at it and they wrote a paper on it. I haven't dug into what they found or their review, but there were a bunch of people that had existing criticisms that I was aware of. But yeah, that I just feel like anytime you put something out, especially nowadays, right? Like if you're going to claim something on the internet, someone is going to
It'll.
have no life and they
Yep.
will go down a really deep dive in Google and you will be exposed
Yep.
eventually. And it happens all the time. And
Yeah.
yeah, so I mean, I do think I don't think that that's nothing. I think that that's very meaningful, especially in the scientific community. If you are producing research that's really interesting or cutting edge or something like that, people will want to see, they will want to piggyback off it and see, hey, like, what else can we do? And,
Right.
I guess bad science will usually get exposed.
Yeah. I think eventually it does, because oftentimes, if it's too good to be true, it's probably not true. I mean,
Mhm.
as you know, you're familiar enough with science to realize that whether it's a training study, a nutrition study, I mean, if you gain a couple kilos of lean body mass, it's like, whoa, that's great. I mean, 2 kilos.
Mhm.
But if you're gaining 5 to 10 kilos, it's like, holy shit, what the hell are you guys doing? 5 to 10 kilos of lean mass in 2 months. So yeah, I think, when people become familiar with the data and they see something that seems a little off kilter, I think eventually, you're right, there will be someone who just goes down that path. It's like, okay, why are these numbers so weird? But yeah, eventually you get caught.
Yeah, and that's something that's not necessarily like apparent to people who aren't really involved in the industry, right?
Right.
Everyone likes to refer back to cancer or not cancer research, research on smoking, right? And oh well, researchers proved that smoking was healthy, and it's like, well, that's not exactly what happened at all, actually. But there's always kind of reference to that. So I do want to actually ask you a little bit about some of the existing limitations that researchers face. Initially, you mentioned there's quite a bit of obstacles to actually get a paper published in a journal. So, what are some limitations they face, both like just technically, and then also, um, I guess, just even from a standpoint of like recruiting subjects and maybe getting their study approved by an IRB, things like that.
Yeah, I think, believe it or not, you mentioned recruiting subjects. Oftentimes that can be the most difficult part of a study. When you're doing
Mhm.
human studies, first of all, you don't want to waste anyone's time. Second of all, if they volunteer, you don't want them to drop out, because otherwise now you're just wasting everyone's time. For the studies I've done, particularly some of the higher protein diet studies, subject recruitment was brutal. I mean, you'd think it's easy. Hey, come on, you'll get free protein. We'll do all these cool measures. And people are like, I don't know. I don't know if I want protein that bad. I'll just go to GNC and buy my own protein. So subject recruitment is definitely an issue. The other one is when typically when you're working with students, you have them for a very limited time frame. So you're like, okay, you're here for maybe another year, maybe just a semester. I got to train someone else after you leave. So in universities, typically you'll notice studies sort of fit within a semester time frame. That's why you don't see 6-month studies, 1-year studies. They're there, but they're kind of rare. So that's why people are like, why is the study only 8 weeks? Well, there was only 8 weeks left in the semester, and so that's what we did. I mean, so a lot of it is it's sort of measures of convenience because that's all you can do. Also, another thing that's interesting for people who are, sort of tuned into research is that you'll notice certain labs tend to do certain things. Like, for instance, if you look at data on muscle protein synthesis, you're like, wow, it seems like it's the same labs that do this. And the reason is they have the equipment. It's sort of the old adage, if you have a hammer, everything looks like a nail. Well, if your lab is great at doing muscle protein synthesis, guess what? That's what you're going to set up your experimental paradigms to look at MPS. If your labs are great at body comp, guess what? You're going to look at the body comp. It's expensive to divert lab. Specialization is needed because of cost, because it does cost a lot. And
Sorry, you cut out
there's
there
a
for a little
training
bit.
issue. You can't possibly care of that. In that, when science, yeah.
I cut
I'm
out where
sorry.
it said, it cut out when you were talking about muscle protein synthesis labs and everything looks like a hammer.
Yes. Yeah. I was saying that, if you have a hammer, everything looks like a nail. And that's why labs tend to do the same kinds of research all the time. It's like if you look at muscle protein synthesis, there's like 3 or 4 labs that's all they do. Look at body composition. There's a few labs that's all they do. Like I'm starting to venture in sports neuroscience, but not because I know neuroscience. It's only because I'm friends with a neuroscientist who wants to do research in it. So I would say you can't be an expert in everything. Just be really good at one thing, and then hopefully you can't possibly.
Well, that's essentially what Brad Schoenfeld's done. Like, I know he gets some criticism sometimes, but he's kind of made a career out of doing one study over and over and over and changing one thing every time, which is, on the one hand, it's not necessarily anything crazy new, but I think it does really open up the landscape of like, okay, we have a much better understanding of these specific things that we already knew about, but we understand them contextually a lot better. What are some, I guess, changes that you would like to see happen in the sports science field?
Well, it's funny. It's sort of alluding to our earlier conversation. I wish that people would do more original investigations and less meta-analyses and review papers. Unless, of course, the people doing the meta-analyses and review papers are the ones doing the original investigations. I think we've gotten to the point where people are happy just summarizing everyone else's work, when in fact, you need to do original work. I mean, that's original work drives the field. We absolutely need more of that.
And to be honest, that actually isn't really something that I've even thought of. I guess I'm not a researcher. I'm just an avid reader, and so I guess it's not something that really ever crossed my mind. But that really makes a lot of sense.
Well, just think about this.
Yeah.
Next time you read a paper, a review or meta-analysis, ask yourself if those people have done original investigations in that topic. And if they haven't, then I think the next question is, well, what makes you qualified to do a meta-analysis or review?
Right.
These are legitimate questions. It doesn't mean they wouldn't do a good job, but it's just one of those things where, if you're going to do one on protein, make sure you've at least done research on protein. I mean, to me, that's not asking for a lot. Right.
And it is a concern that I've had sometimes when I see study designs or programs that are looking to measure something, when it's like, okay, well, you're trying to apply this to powerlifters, like it says in the title something powerlifters, and yet it's like no powerlifter ever does isometrics or this or you know what I mean? So it's like,
right.
Is it really relevant to the sport? Is it relevant to how we train? It's just
Yep.
And so that's always something that I've been a little bit I've actually liked that there's been a big uptick in terms of the number of researchers who actually like lift, who do participate in, you know, different competitive endeavors, which has been really
Yep.
cool. So one other thing, I guess, that I'd love to hear feedback on is, in your opinion, what are some of the things that we can do to take some of this research and distill it in more accessible forms to the public?
Yeah, wow, that's, you know what? That's a good question, and it's a question that I asked way back when, before I even started graduate school, because there's a bit of a translation loss from science to the lay public, and you need, it's as if you need people who are science savvy but are just great general communicators. And believe it or not, there's not many people who can do that. It's kind of hard to do. And so in essence, scientists rely on, I guess a good example would be, there's a lot of people with let's say master's level education. They may not have done the studies, but they are savvy enough that they could read a study, interpret it, and then write it in language that's consumer friendly. And we need those kinds of messengers. And in fact, at the ISSN conference, most of the people who attend are not PhDs. They're typically personal trainers or dietitians. And they become sort of the communicators for scientists. You know, scientists present all this esoteric data, and they're the ones who sort of spread the message to their clients or people they train. So there's no easy answer to it, because interpreting science is, you know, for the lay person, it's just hard. It really is. It's just hard.
Right. No, and that makes sense. So last question before we end off here. What's one opinion you have in the sports science realm that is maybe a little bit controversial or somewhat goes against the grain, but you feel confident enough to kind of put your name on it?
Yeah, I don't know. Here's the thing. I don't know. I don't know if I hold any that are necessarily controversial, particularly with the audience I typically talk to, whether it's sports scientists. But usually they're controversial when I talk to clinicians, oddly enough, physicians, clinical dietitians, et cetera, et cetera. When I talk about super high protein diets, we're talking, let's say, 3 grams per kilo. I take the position that it's safe and that there's no evidence that even doing it long-term would be harmful. And one of the things I like to do is use evolutionary biology as sort of a way of understanding both exercise and nutrition. So from an evolutionary biology standpoint, you realize, okay, let's say 50,000 years ago, humans were basically nomadic. They weren't farming. Now, this is before the agricultural revolution. They had to kill food, basically, because animals provided the most nutrient or calorically dense foods. I mean, you can't eat berries all day, you die. So you kill an animal, you haven't eaten for 24 to 48 hours, so you're literally starving. What human in the right mind would think that there would be a limitation how much protein you could consume in one sitting? You haven't eaten for 2 days, you're going to eat a hell of a lot more than 30 grams of protein in that sitting. You might end up eating 100 to 200 just because you need calories, you need protein. And that's why it always puzzles me when people come up with these weird limitations on humans. It's like 30 to 40 grams per meal. Okay, that doesn't even make any sense from an evolution standpoint, because imagine if we evolved, that's our evolution. 40 grams, that's it, you're done. We'd be dead. We'd literally be dead. Unless we had a refrigerator, 50,000 years ago. It's like, okay, I need to eat again. Well, no, that's just not how the human body works. So I think the one thing I would implore people in the sports sciences to do, and I think with the advent of everything being specialized, people forget that the underpinning of exercise science or sports science is still biology. And the underpinning of biology is still evolution. And I think it's important that we understand things in terms of evolutionary theory. In fact, one of my favorite classes as an undergrad was I think it was called ethology, but we covered a lot of evolutionary behavior. And I think it opens your mind as to why humans can do things the way they do. It opens your mind as to, how come it's so hard to put on skeletal muscle mass? Well, because evolutionary makes no sense. Why is it so easy to put on fat mass? Well, because evolutionarily it makes a lot of sense. So these are things that if you haven't had that biology background, you just think, well, you don't realize that there's just sort of this global underpinning for all of it.
Yeah, that makes a lot of sense. And I guess it kind of comes down to understanding some of those more fundamental frameworks versus just understanding a bunch of arbitrary rules. And that way you can
Right.
have a much more broad application of the rules that end up being important down the road.
Yeah, and in fact, I'm glad you brought that up. The idea of understanding the frameworks. It's and this is what annoys me about. I don't know how you feel about most training studies, particularly when it comes to muscle hypertrophy, because that seems to be the big thing in our field. What annoys me about those studies is that when you look at it pragmatically, if you know the basic principles of training, overload, specificity, detraining, individuality, variation, there's a million ways to get to the same point. And let me throw the analogy out to you. And if you were to take the extremes, so you got bodybuilding on one side, let's say you have distance running on another. Distance running science or distance running coaches are never looking for, what's the ideal number of miles to run per week? They don't ask that. It's a stupid question. It's like asking, what's the ideal number of sets and reps? It's a stupid question because there is no ideal. It's different for everyone. So what does a coach who trains distance runners do? Well, seems that 40 miles a week works for you. 80 miles a week works for you. We'll play around with speed work a little. We'll tailor it. So what do? They follow basic training principles. If you know the basic training principles, worrying about sets and reps and number of miles done it's a waste of time. It's an absolute waste of time because there are multiple ways to get to the same point. All roads lead to Rome. So when I see these studies, whether it's in weight training or in aerobic activity, it's like, I don't know. That's one of my pet peeves. I just get annoyed when I read this stuff.
Yeah, so I actually tend to agree with that quite a bit. I find personally anyways, the more experience I get as an athlete and as a coach, I'm less convinced that any particular strategy is really the defining factor of why an athlete becomes very good. And I'm more convinced that it has to do with things like intensity of effort, consistency, recovery, and remaining injury-free. And then however you push really, really hard, I don't know that matters as much as people think, especially when you look across the spectrum of how people are accomplishing these things. You look at Westside, you look at Chico, you look at everything in between, and they're diametrically opposite in many ways. And so it's like, okay, well, if they're all working really, really well, I think it's more just, effort than anything. And you just have to find out where you land on that level of like what's going to allow you to generate the most effort or to sustain the highest level of effort for the longest period of time while staying injury free. And then once you find that spot, you just keep hammering it until you're as good as you can be,
Yep. Yeah, absolutely. I agree with you.
Awesome. Well, it was great chatting. I don't want to take up any of your time. Where can listeners find you?
Easiest place to find me is my website, issn.net. We have conferences and webinars that we hold regularly, and also I'm on Twitter, Facebook, on Instagram. Instagram is probably the most common way I communicate on social media. My Instagram page is _ISSN, _ISSN, and I'm easy to reach. I'm easily Googleable. So I thank you for your time. This was a good conversation. You know what I liked about this? It wasn't the typical, so how much protein should an athlete eat? How much water do I need to drink? I'm like, oh God.
Yeah, well, I mean, I find that stuff has been done to death. Like one of the rules that I have is if there's an article out there that exists, I won't write about it unless I can write about it in way more depth and add a whole new spin to it. And so I try and do the same thing with the podcast as well, essentially. So I do appreciate you saying that, though. So all of that stuff's going to be linked below, guys. Definitely go check him out. He's putting out great stuff on a regular basis. ISSN has been known for being a really, really great educational platform for a very long time. So again, thank you so much, Jose. It was great chatting with you, and we'll see you next time.
All right, thank you. Appreciate it. Bye-bye.
Guys, thanks so much for listening. I hope you enjoyed the episode and took a lot from it that you can apply to your own situation to see much better results. I just have one quick personal favor to ask of you. Please make sure you subscribe and leave me a 5-star rating on whatever podcast platform you're using. When you do this, it helps me get better at producing content and increases my exposure so I can continue putting out high quality information for you guys. Next, I want to extend a personal invitation to shoot me a DM on Instagram at Stacked Strength. I'll help you troubleshoot anything you need. This is literally an invitation to connect with me directly, so make sure you head on over and jump into my DMs. All right, guys, thanks so much for listening, and I'll see you next time.